All right, hello everybody, and welcome to our July Altinity webinar. I am joined today by Prathamesh from Last9. Last9, if you haven't heard of it, is a pretty awesome observability platform that we're going to be talking about a bit more today. The overarching topic, of course, that we're going to be talking about is observability on ClickHouse. You've probably seen this, right? Even on Reddit, it's gotten to the point where this is like the butt end of a joke. Like, oh, it's another observability platform using OpenTelemetry and ClickHouse. So you've all been hearing a lot about this, and we're going to talk about like how you can actually do this for real at production scale, not as a toy demo, which Last9 has a lot of experience running using ClickHouse backed by Altinity Cloud. So the problem really is driven by the size of the data, right? Like this is sort of the root of the observability challenge today, which is being driven by multiple compounding factors. First, we have more people than ever before deploying workloads. Those people are deploying more workloads than ever before, and those workloads are generating more telemetry than ever before. So even all of these things, which are themselves potentially nonlinear, compound into a very nonlinear growth in the size of observability data sets, just both for individual organizations and especially for observability vendors that are trying to deal with multiple organizations. So what does that mean for you?
Yeah, so observability in 2026 and how a vendor should look at designing an observability product is something that I will talk about today based on our experience with Last9. Typically, when you talk about observability products, you talk about logs, metrics, traces. But as Josh rightly said, it is all collapsing because at the end of the day, it is all data. And you don't know who is generating that data, right? Because it has become very easy to generate telemetry data with all the OpenTelemetry, all the auto instrumentations, and even eBPF, right? It is advanced to a stage that generating telemetry is no longer a problem. Containing that telemetry is a bigger problem that we are all running into. The user experience expectations have not reduced at all. People do want experience that they're used to, that they are already using. They don't want to change their workflows, which also makes it very difficult to build an observability product. And at the same time, agents are also here, right? So it's no longer just humans who are going to access the data. Agents are also going to access the data. So it also means that you have to worry about how the agent experience is going to be, not just the developer experience. So these are some of the observations and trade-offs that we have to build an observability product in 2026, considering all of these factors. And we'll, of course, talk about it today.
Yeah, definitely. So a quick note from our sponsors. As I mentioned, I'm Josh. I work at Altinity. We do hosting and support for ClickHouse. As you're going to hear, though, we also do it in your own cloud. We offer enterprise support. We are contributors to ClickHouse, the open source library, but importantly, we are not affiliated with ClickHouse Incorporated, the company.
My name is Prathamesh. I am from Last9. We are an observability platform, not just for humans, but also for agents. Developers, SREs, AI agents, all can use Last9. We do use ClickHouse a lot, and we also use Altinity. We'll talk about some of the challenges and how we use all of this today.
So quick agenda. We're going to talk about what it looks like to architect an observability platform that can actually handle these challenges that we've been mentioning. We're going to talk about why ClickHouse is an awesome solution for dealing with those challenges. And then as awesome as ClickHouse is, right, it's not a magic bullet. So how does Last9 do it at scale and deal with some of the challenges that are still present? And then we're going to talk about why BYOC, like why both of these offerings you can run together in your own environment. So why would you want to do that? Why is that important? Then we finally have the best part, right? The actual demos. We're going to click around and see some things, see how this all actually works together. And then close off with some fun but horrifying tales from production. So architecting the observability platform. Prathamesh, want to tell us about this?
Definitely. So typically, when you're working on an observability platform in 2026, you will always hear two names. One is OpenTelemetry and second is ClickHouse, because you will see a lot of vendors and a lot of people building observability solutions on these two tools, on these two platforms, because they have made it very easy to get started. OpenTelemetry, of course, has made it easy to get started from an instrumentation perspective. And ClickHouse has made it easy for us to sort of dump any and all data into it so that we can use it for different use cases for logs, metrics, traces. Even some people have attempted profiles as well. So it has become easy to sort of get started with these two tools. But observability is not just the storage layer or the instrumentation layer, right? Observability also includes sort of other things which are also important from architecting an observability platform. What has not changed, although, is that there are three things that sort of are always in tension in terms of the observability. And the solutions around it, which are basically cost, performance trade-offs, and so on. So those are very important in terms of architecting the observability platform as well. Scale is another challenge. We have seen people pumping massive amounts of data in these platforms like ClickHouse, and it becomes very important to sort of design a system around ClickHouse or design a system around OpenTelemetry that works seamlessly rather than sort of just focusing on the storage layer. So these are some of the important considerations when you are architecting an observability platform today, because you have to also worry about how people are going to experience the data, how they are going to consume the data, in which formats, in which protocols. You have to also worry about how the data is going to be stored, for how long, how are the access patterns, who are going to access this. So you have to consider all of these things in terms of architecting an observability platform.
Definitely. Okay. And as with anything, right, I think it comes down to trade-offs. Um,
Yeah.
we go ahead.
Yeah. So cost is almost always the important trade-off. You don't want to spend too much on your observability platform. The budgets are not increasing. In fact, a lot of times these days, what is happening is that the AI budget is eating everything. The tokens cost is so high that people are optimizing all other things for that rate. And it sort of is the biggest contributor to the overall engineering cost these days. So cost is definitely one of the very important aspect of the observability platform, and any potential buyer does consider the cost of any observability platform, not just of usage but also migration, experience, and so on as well. Performance remains the key with all the data and all the agents and humans accessing it. It becomes paramount that the platform is designed to be performant for different use cases, for different access patterns, and the UX as well. UX as well as the AX, which is the agent experience, also becomes the important factor. So I would like to sort of consider it almost like a Rasmussen's area of influence or circle, where all these three things are pulling the equilibrium point to each other, and you're sort of designing a system where you want to maintain the equilibrium at the center, because you don't want to go too high on cost, go very low on performance, or go very bad in terms of user experience. You have to sort of figure out a cost effective but performant and a good user experience for the users, and that remains a key design principle for all the choices that you have to make to sort of design an observability product. So this is like a triangle that sort of you have to worry about and always think about when you're designing and architecting an observability platform.
All right. So what are the components?
Yeah, so typically when you talk about observability, we only talk about the storage layer or the query layer, but it actually starts with instrumentation. And instrumentation is where all the data gets collected and generated. One of the challenge that OpenTelemetry has solved is sort of the standard for instrumentation. But we also have a lot of other instrumentation that is outside of OpenTelemetry as well. Just as a case and example, most of the times I have seen that people have traditional logging. They don't use the OTel logging, right? Because changing logging is an extremely hard job for any engineering team. Also because we are used to the logging patterns, right? But at the same time now, you have to worry about sort of managing the traditional logging with traces that are coming from OTel, with metrics that are coming from Prometheus or something like that. The other challenges around instrumentations are also about SDKs, right? OTel SDK keeps getting updated. It's not expected that everybody will always be on the latest versions of collectors, SDKs, and so on. So it becomes extremely important to sort of design a platform that sort of handles all of these cases as well, so that the user experience is not impacted. Ingestion is again critical because of the nature of instrumentation, which is where data has different shape, volume, variety, and velocity. It becomes very important to shape the data at the ingestion layer. What I mean by shaping is, for example, if you have logs, you can extract relevant attributes, standard attributes at the ingestion time itself, which can act like caching when you actually query the data. Right? At that time, the query don't doesn't have to go on the raw data because you can extract and sort of remap certain attributes, and we'll see some of the examples of that as well today. Storage again becomes critical. How you architect the storage, what is your hot storage, cold storage patterns, how you're sort of retaining data for longer duration. Are you creating some materialized views, rollups, fast metrics to sort of manage the access to the data dependent on the use cases? Query layer again is what we know already, right? Different patterns of access. Do you want to access data using SQL, LogQL, TraceQL? All becomes sort of important because the expectations of users are also that, hey, we don't want to change our workflows. I'm used to Grafana. Let me use Grafana. It doesn't matter what's the backend is, right? I'm sort of used to my dashboards. Let me see the same dashboards. Or if I'm doing the migration, I want to sort of see the exact same names of the dashboards and alerts that I'm used to in my existing platform. Alerting again becomes very critical. And what has changed in the last 6 months at least is, or even slightly before that, is how agents are sort of dominating everything and become a central theme of every observability vendor or whoever is sort of dealing with observability, because everybody wants to build their own AI SRE. I have seen people, like at least in my experience, the trend has been that people want to build their own agents and SRE agents or different types of organization agents to access the telemetry data, combine it with other data sources as well, which means that I have to sort of make data available for agents as well. So observability is not just the say storage and you build a query layer on top of it and sort of access that data. It is a combination of all these six things, and because of which what becomes very important is we have to design a system which works together rather than in isolation, because if you are instrumenting too much data, then you have to define or build an ingestion layer which can handle that much amount of data, that can handle spikes, that can handle sparse traffic if it is coming. You have to design the storage layer that is connected to that ingestion layer so that data can be correlated, data can be stored in an optimized way. You have to build a query layer on top of that storage layer so that the query utilizes all the optimization that you have done at the ingestion layer and the storage layer, right? So it's the entire system together working as a team is what observability is. It is not one aspect of it in isolation. And that also drives your design decisions because the trade-offs that you make at the ingestion layer can help you reduce cost at the query layer. For example, if you're building some aggregations or roll-ups at the ingestion layer, that can help you reduce the query cost because you don't have to heavily invest into the compute that is required for very high load queries, right? Any optimization that you maintain at the ingestion layer for handling data spikes or even creating some buffered views and so on so that the pipeline sort of ingests the data helps you handle spikes which can go from let's say 100K to 300 million, which we have seen actually in production where one customer just directly jumped from 80K to 350 million in a couple of minutes, and the system had to sort of scale for that traffic to handle the ingestion and the storage and everything. So observability is not one part of it in isolation, but it is actually a system which works together. And these are the six stages. Agents is almost like a agentic access. So typically there, you can combine it with query layer as well. It's just that instead of humans, the agents are querying it. But five stages are very critical, which are instrumentation, ingestion, storage, query, and alerting.
And you had those first two in green, which was interesting because they're like
Yeah. So
kind of yeah, OpenTelemetry enters the chat.
yeah, and changes everything.
Yes, yeah. So we both are huge fans of OpenTelemetry, of course. But yeah, it does change everything for both the consumers of observability and the vendors of observability because it changes the responsibility model. So we have this new responsibility model where we're sharing responsibility for the telemetry quality, the generation of the telemetry, and the volume. Also, right, because of that generation is shared, the responsibility for the volume is now shared, and the volume is continuing to grow non-linearly, as we mentioned. So sort of everybody has to deal with that on both sides of this. Oh, ClickHouse enters the chat. So ClickHouse kind of solves the data problem, right? Like, yeah.
Yeah,
So
you can dump anything and everything at ClickHouse.
how?
Yeah, that's a great question. So, I think a lot of our audience is already aware of ClickHouse and has sort of used ClickHouse. So I'll not go into too much technical details of what is ClickHouse and how sort of its architecture is different. But one of the key advantages of ClickHouse, especially for observability use cases, and which matches the data model that we have today, right? Where you can generate data from any source. That data can have any shape, log, metric, trace, profile, doesn't matter. You can dump all of that into something like ClickHouse without worrying about hey, how to ingest it, because of course there are collectors and sort of ingesters that are already available. So it allows me to literally dump anything and everything into the ClickHouse storage. SQL is a very standard uniform way of accessing data, which a lot of us already are used to because of other tools that we are already familiar with. But because it is SQL, I can also build a query layer on top of it where I can control the user experience. I can give people a flexible way of accessing that data in other query languages that they're used to as well. So there is a standard, right, which allows me to sort of build solutions on top of it from a single unified data source. And of course, it has proven at scale for very large volume as well. So I don't have to worry about, hey, my labels are increasing. I want to track each and every customer of mine so that I can understand the API performance for every customer. I can just create a field for it and sort of design the schema in a way that it is able to handle that kind of cardinality or whatever the label dimensions that you have. So that makes it extremely sort of viable and useful to use ClickHouse for observability use cases. Of course, there are some challenges of using ClickHouse for observability use cases as well, which you have to circumvent or build solutions around it. If you are like used to Elasticsearch kind of a full stack search experience, then you will find, of course, like there are now full stack search available in ClickHouse recent versions as well. But those are some of the challenges that you will run into. Now, users migrating from an existing ELK stack will ask you about how you're doing full stack search or how should I search on body. But that's where sort of the system that we discussed earlier, where the system that you build around ClickHouse helps you navigate that, because you can build some indexes. You can use the existing features of ClickHouse, which are not really full text search, but allows you to do fast searches on raw strings in a text body, sort of help you, right? So while that is there, it does allow me to dump a huge amount of data in a predictable way, and that sort of makes it very viable and useful for observability use cases.
Yeah, I mean, especially that point about cardinality, right? To me, cardinality is one of those things where if you don't have an engineering solution for it, it takes up a disproportionate amount of your mental load whenever you're doing anything else. Um,
Yep.
and it just, you don't need to be thinking, you don't want to be spending that much time thinking about it if you can have an engineering solution that solves it for you. Um, okay, so nuts and bolts.
Yeah. So together, ClickHouse and OpenTelemetry are sort of meant for each other in a way, because there are open source exporters in the OpenTelemetry world which are available for ClickHouse. So you just can just plug it in your existing hotel collector and send data to ClickHouse very easily. There is a Grafana data source that is also available for ClickHouse if you want to just access the SQL data directly from ClickHouse. Uh, there are default schemas that are also out there, right? So even if you just sort of download the default schema and start using it, you can sort of build a quick observability solution within a half an hour as well if needed, right? At least as a getting started point. Of course, like scaling and all of that comes into the play. It also allows you to do isolation in terms of read-write traffic, which becomes very important when you are handling scale, because you can decide the resources for each of the layers dependent on how much traffic you're expecting and so on. So OpenTelemetry and ClickHouse are they have a good support for each other, which makes it easy for you to use something like OTel to send data to ClickHouse as well. I should also call it out here that a lot of data that we see, like that we see at Last9 as well, a lot of the data that customers have is not OTel, right? Uh, while OTel is mainstream and basically has auto instrumentation for multiple components, even serverless components are there, right? But there is huge amount of data which is not OTel. But you can dump that also within the same pipeline by designing solutions around it, right? Like you can get data from, say, if you want to ingest Cloudflare logs, for example. Uh, OTel has a receiver for it, for example. If you want to ingest logs from your Kubernetes clusters or Docker containers, there are receivers for getting those file logs as well and sort of dump it into OpenTelemetry. People have built adapters in terms of transforming one format, line format, into another line format, where let's say you have a Fluent bit that can be converted into OTel as a plugin and then ingested into OTel format and so on. So a lot of data is not OTel. You can still dump it into ClickHouse, which again proves that earlier point that we discussed about, where you can sort of consolidate all the data together and then uh, make sense of it or query it to understand what your system is doing. But Hotel and ClickHouse have a good support for each other, which also makes it extremely easy to sort of unify the different amount of telemetry data together.
Yeah. Yeah, a common pattern I'm seeing here, and I think this is important if you're using this exporter, is to have like a collector deployment running somewhere as sort of a gateway to the data store, not having every, like if you have daemon set collectors deployed on your cluster, don't have each one of those connect to the ClickHouse cluster. Because it'll, we're going to talk a lot about how important batching is when you're inserting into
Yeah.
ClickHouse. And so yeah, you want to have a centralized point to control that batching.
Another interesting point about the gateway collector, right, is also sampling decisions,
Yes.
because like we sort of always hear that, hey, sampling, you should do sampling to reduce the data. But if your collectors are not sort of connected in a way that they have all the trace data to make the sampling decision, it is almost always going to do the wrong kind of sampling, where you will miss out on the data. So uh, what we sort of at Last9 at least, right? What our recommendation to a lot of people is also that, hey, instead of sampling, you can cut down the noise by removing unwanted spans and sort of removing internal spans, because there is a lot of noise that these uh, Java SDKs and .NET SDKs create for internal spans. So that also sort of plays an important role. I'll cover that when I talk about sort of the
Yeah.
entire architecture of Last9. But just wanted to talk about that because that's where the part about treating it as an entire system comes into the play, rather than just treating Hotel or ClickHouse together and sort of do the magic and everything is solved.
Yeah. Yeah, sampling, just like cardinality, another one of those things you don't want to spend a disproportionate amount of your effort on,
Yeah.
if you don't have to. Okay, so let's talk about Last9 architecture and how you specifically address some of these challenges.
Yeah. So I'll talk about how Last9 tries to address a lot of these challenges. We'll also see like what people have today, right? So if you just move to the next one, it has details about on the ground challenges that we see as an observability vendor, right? Typically, like I said, people have some hotel, but they also have a lot of non-hotel that is out there by default, and it is very difficult to migrate it on day zero. Of course, there are efforts and initiatives that people have to sort of convert it into a standard data. But it takes immense amount of effort and time for developers, engineers to sort of stop all the other work that they are doing and allocate a lot of time to do this, right? So instrumentations like eBPF becomes very important for a lot of these things. Lack of structured data at the instrumentation time also results into slow queries and performance impact or correlation challenges when you query the data. But I'll talk about like how we look to address that as well. A lot of times people come from multiple tools, like logs are in ELK, metrics are in Prometheus. For APM, they're using some vendor. So there are already data silos, right? which is an opportunity for a unified solution, because when they see the data and you can jump from log to traces, and then you can see a metric and quickly set an alert, that becomes a great user experience story for them, because they're not used to that kind of an experience. So in that case, the unification sort of helps, because you're able to show the power of all of this put together, in which you can correlate and sort of jump between the data points. There are always some business specific needs, right? It is not just that you do auto instrumentation and everything is done. You want to have some SLOs. There are some business metrics that you want to capture. Logs have a lot of business context. It's very hard to do like metric instrumentation or hotel instrumentation for that. Logs have a lot of relevant context, and you need a way to sort of extract that information for business alerts and other use cases that you want to build. Managing alerts is again a big challenge. There have been a lot of efforts with agents and models sort of to solve that, but that still remains a key challenge, because setting thresholds, managing them, is just a nightmare. Nobody wants to sort of keep doing that all the time. And all of this sort of results into lot of data that is there, but it's harder to sort of get insights from that, right? And this is amplified now with AI, because uh, even if you have AI and a lot of data and you have means to query that raw data converting into aggregation, then deriving insights for it, it also means that you have to spend a lot of tokens, and those tokens can be very expensive, which we have seen in the wild, people spending huge amount of tokens for all of this telemetry data. So while people want to build AI SRE solutions or agents for telemetry and observability use cases, it almost always needs a agent cache sort of a thing, which sits on the raw telemetry data, but which gives agents structured, correlated information that they can use for actually doing the investigations, right? So that also becomes pretty much important for like using this all of this data with AI as well. Legacy code is a very common challenge. It's very difficult to migrate those systems of whatever stack they are in. They can use older SDKs and so on, right? So you have to almost always build a system which sort of compensates for the versions across different releases of Hotel, and make sure that the system manages all of these naming conventions, because Hotel keeps changing naming conventions. Earlier it was HTTP dot status dot code. Now it is HTTP dot status underscore code, right? And now all the dashboards, default dashboards that you have built are broken, because people updated to the new SDK, and then the keys change. So you have to almost always sort of keep track of all of these instrumentation libraries. The one of the interesting actually point about this is why this was not a problem before sort of Hotel, right? Is also because earlier vendors used to have their own agents for instrumentation, right? Like a Datadog agent or a New Relic agent. So the experience was managed end to end. But now, if I'm building something on top of Hotel, I have to sort of build a experience which is compensating and sort of solving for different types of SDK versions and so on, right? Because I can get data from any source. It doesn't matter from where I will get the data, right? It is Hotel standard. Anybody can build their own SDK also and sort of build their own layer and send me the data as well. So it forces me to rethink how I want to build a platform to sort of solve for these challenges. And we'll talk about how we try to address this at Last9 as well. But these are some of the extremely key challenges that we see on the ground, which makes it very interesting to solve these problems as well.
Yes, interesting is the right word. And yeah, oof.
Yeah. So
Okay.
whenever people want to sort of try and what they expect, right, from an observability product like Last9, of course, unification is very appealing because of the existing data silos and just the promise of seeing all data together, even though it is not needed at times as well. But just a single source of truth in terms of the unification makes it very important. Unified telemetry, again, is the same sort of a point. It also allows us to build centralized control over the telemetry, because everything is getting ingested into one place. I can sort of connect the data together. I can build correlations at the ingest time itself and use that later for uh, the query. or the dashboards or all of the other experience that can be built on top of it, which also helps in reducing the data or reducing raw data or noise and give key signals to the customer. So uh, these are some of the things that customers need. Even though we have hotel, we have ClickHouse, we still have to solve these challenges as well, which are on the ground challenges, and that's where sort of what we are trying to solve for. So we can move to the next one.
Okay. So this is, yeah, these challenges, right? Like you deal with all of this as a signal organization. And then as an observability vendor, you have to deal with this for multiple organizations.
Yeah.
And this presents a bunch of new challenges. Um, right, like you mentioned, just the one customer who had that spike from it was 80,000 to 300 million, something like that. Yeah. So that's one customer, and then
It's one
that
customer. Yeah.
that can impact your other customers in addition
Yes.
to being a challenge just for that one customer's environment. Um, so yeah, multi-tenancy definitely creates some challenges, but also, right, we've been talking a lot about single unified source and centralization and the benefits of that. So there are definitely some trade-offs here. The central one, right, is cost versus quality of service. You can basically not do multi-tenancy, which is the choice that we've made at within Altinity, right? So all of our, whether you're on our managed SaaS or our BYOC, every ClickHouse cluster is its own Kubernetes cluster. And we made the decision because at the database layer, right, like we just sort of decided as a company, the second worst thing that could happen is that we lose data. But the worst thing that could
Yeah.
happen to us is that we show someone else's data. So we don't want to do that. And we also want to guarantee the quality of service because the types of production workloads that our customers are running on their ClickHouse clusters, they need that type of control. Like you're one of our customers, you need that quality of service so that you can then pass that on to your customers. But that's not always the right trade-off, right? Like sometimes if you want to be able to really quickly cold start an environment, multi-tenancy can create a lot of challenges. It's also expensive, right? And creating small, developer and sandbox environments gets really expensive when you don't have architecture support for multi-tenancy.
Yeah, one of the other important aspect of multi-tenancy is also the architecture in terms of compute and storage, because what you need to sort of think about in terms of multi-tenancy is also what layer of your stack or the platform you want to be multi-tenant, right? Uh, there is almost always a auth gateway or something which can be common, which is a very lightweight auth gateway, which can sort of fan out to the actual individual deployments per tenant and so on, right? But it also means that there is a ease of use in terms of maintenance and uh, like entry point to your architecture. But beyond that point, then you can sort of distribute the system in a way that every tenant gets isolated compute, isolated storage, and so on. It also allows you to build. So, for example, what we did was we created a proxy API layer for accessing the data, right? So nobody could actually connect to ClickHouse directly. Was one of the decisions that we took early. Again, there were reasons for it, pros and cons, and of course trade-offs as well. But one of the reason for doing this was also to manage the experience in terms of the output of the data, right? We were able to optimize the queries in a way that we were able to give a better user experience because of that query API layer. We were able to cache few things. We were able to sort of manage the attributes that we query, how we query, and circumvent some of the full stack search problems that we discussed earlier as well. Right? That allowed us to sort of build that layer on top of it. And also it allowed us to support multiple query backends, like LockQL was possible. Even a proxy SQL layer was also possible at times, right? So while multi-tenancy is a important aspect for any team which is sort of serving multiple customers, there are ways of architecting it so that it doesn't really remain multi-tenant. You can leverage the usefulness of single tenancy architecture as well. And that's where I think our experience with Altinity also came in handy, because we were able to sort of use the single tenant architecture for the actual storage layer. With Altinity, which also solved a lot of problems for us from in terms of the quality of service and cost that you mentioned. But it is almost always interesting how you want to sort of look at the multi-tenancy problem, because it not just affects the user experience, it also affects how you onboard customers. it also affects your deployments, right? Like, for example, if I have hundreds of deployments for hundreds of customers, then I have to design a system for deployment itself. So that any new change that I want to roll out, let's say I added a new sort of a query function optimization in my stack, rolling it out to 100 customers automatically without any glitch in between is itself a problem statement that your engineering team has to sort of address from a ground up, right? When you're designing this system. So the trade-offs or sort of the impact of these decisions can be widespread, right? And they can impact how the rollouts happen. They can impact how fast your releases are reaching customer. They can impact how fast you can upgrade your software as well. Sometimes they can also impact whether you can even touch the software or not, right? Because sometimes you can't even look at or sort of touch a piece of software as well. So multi-tenancy does play an important role. What we have realized over time in our experiences, there are components that we want to have single tenancy. There are components that we are okay with having a multi-tenant kind of a compute or a like a intelligence layer. But with Altinity, of course, right? Like we are able to sort of move the ClickHouse layer to a single tenancy kind of a setup. We are able to serve the customers better.
Yeah, that's a great way to navigate all of those challenges is, building tools, right? Like manage the pipeline that produces the outputs instead of managing
Yeah.
the outputs. Yeah. Okay. Speaking of pipelines.
Yeah, so this is where sort of all of these things that we spoke about come together to solve the challenges that we discussed, right? This is the Last9 telemetry data platform, high-level architecture, and how it works. I'll also cover some parts of it in the demo as well. But essentially, the telemetry data platform has a data platform, which is where you can dump any data. But it also has a control plane, kind of an intelligence layer, where you can decide what to keep, what to drop. You can shape the data, you can enrich and transform the data before it gets stored, so that when you query the data, it is already correlated, it already has accelerated attributes for you to query. It allows you to transform the telemetry as well. Like if you have a legacy service which only has logs, but for alerting dashboards or other use cases, you want to convert those logs to metrics, traces to metric, then that also sort of becomes well. All of this control plane, the use cases are also solvable from programmatic access as well, either via the AI experience or via or Terraform and IC as well. So you can also control it in different ways. And then again, there is a data platform layer which sort of stores all the data. There is a query engine on top of it, which allows you to query that data effectively. Again, we have gone into a decision of sort of building a query layer on top of SQL, so that people don't have to uh, directly query the raw data. There are some pros and cons of it. Pros, of course, that we can control the user experience better. We can also give capabilities rather than raw data for a lot of the use cases that people have. So, for example, uh, querying the average score of a particular service rather than querying latency and then calculating it on the fly, right? So these are some of the trade-offs that helps you sort of navigate the user experience. Of course, people can query the raw data as well when they want, but you can build sections on top of it which can help everybody, not just the humans, but also the agents to understand the system well. It also allows us to create faster data. I would not say just the materialized views, but we also use some other tricks, like creating fast metrics from certain logs and traces as well, so that there can be different consumers of it from logs and traces perspective. I'll also talk about some pitfalls of materialized views as well that we have seen at scale, because one of the biggest problems for designing such a system is all of this must work at scale as well. And we have customers who send sort of 300 million, 480 million kind of telemetry data points per minute and so on, like 50 TB data, now BAU day. But during IPL, which is like one of the biggest sporting events over the world and very popular sport cricket in India, we have seen people sending us 120 TB of data per day as well and expecting that data to be queryable immediately for debugging the incidents, finding out the transactions, and so on. So that also requires designing this in a way that this works at scale as well, right? So we have some experience and challenges that we have seen with ClickHouse, which we will also talk about. But essentially, this is the architecture where the data platform has a control plane which allows you to shape the data so that you can standardize, extract, enrich the data, drop everything that you don't want as well, only keep what you want, and then query that data using multiple ways, access that data using multiple ways. This sort of highlights it. I'll also cover some of these things in the demo as well, and some of the ClickHouse challenges that we have seen at scale.
Cool. Okay.
And this
I
is
think we talked
also,
about. Yeah, go
yeah,
ahead.
we talked about it briefly, but this is also one of the very important design principle that we have, right? Because one of the design principle in building a product is about accepting where users are coming from. And this is very important when you're building a product, right? Because not all users are used to your way of thinking. They can come from different backgrounds, they can come from different existing experiences. They may not have the liberty or the leverage to do a lot of the things that you are asking them to do. So it is almost like building an observability product for where you are as a customer, as a user, rather than, hey, come to me and I will sort of show you the light in terms of how things should be done, right? So that is also one of the design principle that we have, which also means that access should be available for multiple data patterns, right? Like if somebody wants to use Grafana, use LogQL or PromQL or TraceQL with it, so be it, right? We have built a query layer on top of it, which sort of allows it. Again, it will have some limitations compared to the default, like a canonical implementation of LogQL. But of course, that's the trade-off that you have, where again, going back to that cost, performance, user experience, your user experience is not getting hampered for the cost and the performance that you're expecting. So observability for where you are as a design principle is very important for us as a product, and that also shapes a lot of decisions that we have made for building the product as well. This is one of them, which is flexibility of access. If people want to access data in different ways, it should be possible.
Couldn't agree more. And I know PromQL especially is such a hot topic right now. I can't wait for that to land fully supported in ClickHouse Core. Okay. Oh, let me know. Yeah, just let me know when you want me to hit the button.
Yeah, so these are some of the challenges that we have seen, especially at scale, right? And these are also challenges for which you have to architect a system, not just use a just ClickHouse to sort of use it, right? When there are massive spikes, the merges increases, especially if you are using materialized views, then it also becomes interesting because you can have merges for those materialized views and inserts happening in concurrently with the uh, main table as well, right? At that time, we have seen ingestion getting lagged or impacted because there are multiple queries that are running at the same time, which has caused problems to the health of ClickHouse cluster, right? And some of these challenges are also only encountered at scale. They may not be possible to look at a normal scale, but yeah, we can. I'll give you a heads up to to the next
Yeah.
one. But this is one of the problem that we have seen. Materialized views, while they are great for solving some of the roll-ups and challenges around aggregating the data or only keeping sort of the faster view of the raw data, they can also cause problems if not designed properly. Uh, In the early design days, we have sort of designed few materialized views, which causes problem in terms of ingestion. Now, what we came up with was a slightly different approach. We converted some of those use cases for materialized views into metrics themselves, because we have the ETL pipeline for sort of transforming the data as it is getting ingested. We started using some of that ETL pipeline for our internal use cases as well, for designing these faster access to the raw data. And we did the decision of sort of using metrics for it, which actually proved to be interesting one, because it allowed us to use that data in multiple ways, because it was also accessible via PromQL. Uh, it opened up multiple access levels for that data, which was earlier not possible. So we do use materialized views and they're great. There are some use cases that we solve with materialized views. We have seen at large scale resulting into bottlenecks as well, for which we have sort of shifted to faster metrics, which has been a good performance so far.
Nice. No, that makes a lot of sense.
Batch size is a very common problem if you're using ClickHouse. I think a lot of people that we have today in the audience may have come across this problem. There are customers or people who send like one log line. Like this is an interesting production discussion that I had with a couple of people recently. There was a person who was trying to insert one log line and he was expecting it to be available immediately in the platform. But yes, it
That's,
was
that,
available
that's
immediately.
how it works when I'm running it on my laptop.
Correct. But of course, you have some batch settings in your ETL pipeline where you have to use that so that you can do async insert, right? Because doing one insert in ClickHouse is not good. Like the advice is that you should use async inserts and sort of do batches correctly so that you can insert in a effective way without causing too many queries on the ClickHouse cluster. So batch is one of that interesting setting that you have to manage. Now, this is also one of the interesting point because batch starts at the hotel collector layer, right? Because whenever you have the ClickHouse exporter, you have to define the batch there, but it has impact on your storage layer. And if you're using the same thing for query also, because effectively, if you have a replica or something and using that for query, it has end-to-end impact. Like if you mess up with the batch size in a way, it can derail the entire pipeline together. So you can't keep it too small, but you have to manage it in a way that it sort of becomes dynamically tunable to the traffic levels that you're seeing. So we developed a adaptive algorithm internally which can sort of tune it dependent on the traffic based on ingestion layers, like levels of ingestion, and then it manages it. But this is again a very common problem that I think a lot of people may have seen. And there are, of course, good blog posts and recommendations over. I think Altinity blog also has some good blog posts about that, how to sort of manage it. But this is again an interesting problem that we have seen.
Yes, I see that we were getting some questions in chat. I don't know if we're running a little slow, so I don't know if we're gonna have time for questions, but we do have an
Yeah,
office hours tomorrow. So folks, if you do have questions, just join us for the office hours tomorrow. And Harlan, maybe you can join us and answer
definitely.
any follow-up questions.
Yeah. For
Okay.
production workloads, adding buffer like a Red Panda or a Kafka seems a very common architectural choice. But now you have two problems, right? Because you have to manage the inflow and outflow from the buffer, which is the biggest problem. Because if your ingestion is spiky and you're seeing like massive variations in traffic, now you introduced a middleman who is sort of going to manage the outflow to ClickHouse cluster or inflow from the hotel collector layer or whatever gateway architecture that you have. Now you have two problems to solve. While it has its own pros and cons, what we have seen is that it requires a certain scale to sort of enable this, is what our experience has been. There can be uh, cheaper alternatives to adding something like this in your stack to avoid this without really a need for it. So we do use buffer at places, but we also have a sort of a dual architecture in a way where we can avoid it dynamically.
Classic engineering trade-off.
Yeah. Storage scaling is again consuming. I would say it doesn't happen instantaneously if we expect it to happen instantaneously, which also means that the pipeline parts becomes important. It has to absorb the pressure. It has to absorb basically uh, if there are spikes or weird kind of traffic patterns. Because even if you have to scale at runtime, it is not going to be fast. And a lot of times for databases, you have to vertically scale, which takes time, which means that everything before that has to be sort of tuned in a way that you can save that time. Otherwise, there is a data loss, right? So that is something that also we sort of design few things around how to solve that.
No, we talked about this one.
We talked about this.
Every
Yeah.
time it gives me shudders. Yeah. Okay. Oh, very quickly now, why bring your own cloud? Because for observability especially, I think it just makes sense. First of all, there's no vendor lock-in, right? OpenTelemetry promises no vendor lock-in. I've given multiple talks about why that's partially true, but not as true as the marketers would want you to believe. So having like actually true open source storage combined with OpenTelemetry actually fulfills that promise now end to end of no vendor lock-in. The data lives in your own environment. This is really important for a number of reasons. One, just having the data close to where you need it and close to where it's being generated can save money, right? Like you're not paying for cloud egress costs. So that's a great benefit. But also, right, of course, you might have sovereignty requirements or a reason that you want to actually just keep this data in your own environment and never let anyone else have access to it, which you can certainly facilitate using Altinity managed BYOC. And because it's a managed service, you get all of the benefits of a managed service. So you own all of your data, but you don't have responsibility for keeping the system up and healthy and functioning. We take responsibility for that. And lastly, the costs are predictable because you only pay for the cluster you provision. So you don't ever get charged with a surprise bill for a spike in your telemetry because you're paying for the ClickHouse cluster compute, not for the actual number of events that you're sending. Same billing model for Last9. So if you combine the two tools, you have low predictable costs, especially compared to some legacy vendors. And then this is really cool, right? So ClickHouse is not just an observability database. It's a whole data warehouse or lakehouse now with some of the features that have been added in core and also through Altinity Project on Talia. So it's not just your observability database. You can use it as your whole lakehouse. And also, if you already have a lakehouse, if you already have ClickHouse, you're already paying for that, you're already managing it. Why not also use it for your observability data, right? And so that's why I'm really excited that there is an end-to-end managed BYOC solution for observability with ClickHouse. Do we have time? We have 6 minutes left. Do you want to do like a 2-minute demo?
Yeah, I'll cover a couple of examples that we discuss.
Okay.
Okay, I can share my screen. So what I want to cover was a couple of examples of the control plane aspect that we discussed. So I'll not waste a lot of time, but this is a log line which has a trace ID in it. You can see that trace ID here. Now, the instrumentation is done in a way that this is not an attribute. So correlation is difficult. It is buried somewhere in the log line, and it doesn't sort of help me navigate to the trace. While it has a trace ID, it means that it has associated trace as well, but I can't go to that. And when I go to the related traces, I will not see that individual trace, but I'll see everything, right? So I don't sort of have the ability to jump it. Now, what Last9 allows you to do is at the query time, you can define regexes or JSON extraction rules so that you can extract it. Now, if I click on the same like view details, here I see the trace ID. Here I see the span ID because it is extracted at the query time. And I'm also able to jump to the trace. So the correlation problem is addressed. Even though my logging and tracing is disconnected from each other, I'm sort of able to connect it together at the query time. But now on top of that, what you can do in Last9, and this is the Last9 control plane, where you can define a remapping rule. And this is a rule that I just defined some time back, where the same regex is now added as a rule in the ETL pipeline. So while the data is getting ingested, this trace IDs, span IDs will be extracted as accelerated attributes. So that now when I go and query the data, it's the same service that I have. But if I look at, say, last 5 minutes, I'll have the trace ID attribute directly here. And I don't have to do the regex parsing and all of that at the query time because we are sort of able to do that at the ingest time itself, which also means that whoever is accessing this data already knows that, okay, these are the standard attributes that are available. Just use that to do the correlation. This is the sort of the agent cache example that I was taking earlier, because this also helps agents to query the data predictably, do the correlation, and sort of solve it at the ingest time itself rather than inventing it at the query time. So this is one example. There are a few other examples as well. Now, one of the interesting thing that this also helps is it like this is one of our AI assistant example, but I can also generate a lot of these remap rules and all of that using AI. because it can access the data, it can understand the data patterns. In this case, for this AI agent service, it understood that, hey, the ANSI characters are being printed in the logs, and then it gave me an example of how I should update in my hotel collector if I have hotel collector running. But even if I'm not using hotel collector, I can add the same rule on the control plane itself. And it also allows you to quickly add the rule from the assistant itself, or if you're using MCP, then MCP also has that capability. So it just connects things end to end. For example, an AI agent investigates that, hey, this time I use more tokens because the data was not standardized. But here is a recommendation to add this rule, and it will become standardized the next time you want to query it, right? So that sort of closes the loop on the telemetry. Code change is not needed. You really don't have to change the workflow that you have. But this sort of is one of the example what we discussed earlier about managing few things at the ingest time itself, which can help you later.
But
Yeah,
yeah,
that's a
that's
quick
really
demo.
cool because most vendors are like, trust me when it comes to correlation, whereas you're giving
Yeah,
the customer levers to control it themselves, which is really cool. I think I've taken control back. Okay, so yeah, we had a quick demo of Altinity BYOC, which is your ClickHouse just works. We have tons of content online if you want to go on YouTube and actually find a demo. We do have an Altinity Cloud Manager that makes everything really nice and easy, gives you access to Grafana dashboards and backups and things like that. But mostly, if you're using it with Last9, your ClickHouse just works. You don't have to think about it. We don't have time for tales from production, so maybe we'll do a follow-up session because these were some really fun but terrifying stories. We'll do like a Observability Twilight Zone episode or something. Um, yeah, every time. Okay, so here's a QR code. If you thought this was really, really cool and you want to go check out Last9, I did mention that we have office hours tomorrow where we will answer follow-up questions. I see several people ask questions in the chat and Q&A, so try and make sure that we capture those and answer those in the office hours. Even if you're not present, that recording will go up on YouTube, and so hopefully you'll get an answer to your question one way or another. And if all else fails, come join us in Slack and send me a DM and be like, Josh, you never answered my question. Come on, man. And I will fix that. So that's all. Prathamesh, thank you so much. It's been absolutely pleasure doing this with you.
thank you.
Thanks a lot.